Hey AP Chemistry, I wanted to post another quick video on how to draw Lewis structures. In my last video, I did a very simplified example that didn't really go beyond the octet rule. This example for PF6 minus 1, this is going to have what's known as an expanded octet. Or it's an exception to the octet rule. Remember, the octet means 8. Okay? So for PF6 minus 1, my first step, remember, in drawing Lewis structures is counting all of the total number of valence electrons. So using a periodic table, if you look at the group numbers tell you how many valence electrons each element has. So 1, 2, 3, 4, 5, 6, 7, 8 across. Those are it goes up to 8, and 8 is the octet, where we have the noble gases. So if I'm looking for phosphorus first, which is P, if I look for P, it is in group 1, 2, 3, 4, group 5. It's got 5 valence electrons. Then there are 6 Fs, and each F has 7 valence electrons. F, which is fluorine, is found in group 7. So I'm going to do 7 times 6, 7 electrons times 6. Okay? And so I'll have 7 electrons times the 6 fluorines. And then don't forget that if I have a -1 charge, I add 1 electron. Okay? So this looks a little bit messy here. But basically, phosphorus has 5 electrons, valence electrons. F, fluorine, has 7, and there are 6 of them. And then there's a -1 charge, and for minus charge, you add to the total. So I'll have 5 plus 42 plus 1. That will equal 48 electrons in total. Okay? So that is going to be my total number of valence electrons. My first step in the structure is connecting everything to the central atom. Phosphorus is definitely the least electronegative element, and there's less of it, so it's a central atom. And notice that there are 6 of them. So 1, 2, 3, 4, 5, 6. And this is an arbitrary shape. I'm not doing shapes yet. That's going to be in a later video. Arbitrary of how I'm putting the 6 phosphoruses around, the 6 fluorines around the phosphoruses. Now, there are 48 electrons. Remember, the next step is to subtract from your electron bank. There were 2 electrons in each bond. So 2, 4, 6, 8, 10, 12. Minus 12 electrons. I have 36 electrons left. Okay? Now, the next step then says give all atoms an octet by putting lone pairs. Now I'm kind of combining everything here. First, you start with your non-central atoms, then you move to your central atoms. So each phosphorus has 2 electrons because of the 1 bond. That means each phosphorus is going to need 6 electrons. And if you kind of see that there are already 6, fluorine, I keep on saying phosphorus. Each fluorine needs 6 electrons to get that octet. So I'm going to start putting them on there. 1, 2, 3, 4, 5, 6. Minus 6 electrons, 30. I don't know if you noticed, but there are 6 fluorines, and if I do 6 times 6, that's going to be 36. 5, 6, minus 6 electrons, that's 24. 1, 2, 3, 4, 5, 6. Minus 6 electrons, that's 18. 1, 2, 3, 4, 5, 6. Minus 6 electrons, that's 12. 1, 2, 3, 4, 5, 6. Minus 6 electrons, that's 6. 1, 2, 3, 4, 5, 6. Minus 6 electrons, that's 0. I have used all of my valence electrons now to make this structure. And then if there are any left over, you're supposed to put them on the central atom. Well, there are no more left over, so boom, I don't have to put anything on the central atom. And if I look at the central atom, P has 6 bonds. That is 12 electrons, right? Now, is that okay if it's over an octet? Yes, because there are some exceptions. Elements in group... this one's fixed. Elements in period 3 Sorry, there was one page that had a typo and this one isn't. Elements in period 3 or higher can have over an octet. So phosphorus is found exactly in period 3. It can have over an octet. So things like elements like phosphorus and sulfur, bromine, iodine, they can have over an octet. So this structure is good. To figure out where that -1 charge comes from, it's actually going to be the formal charge that is found on phosphorus. Phosphorus has 5 valence electrons, minus 6 bonds, and there's no non-bonding electrons. So that equals -1. That means that phosphorus has a -1 formal charge. That's where that -1 comes from. Okay? Quickly do one that has under an octet. Elements like boron do not have to have over an octet. So if I want to start doing its Lewis structure, boron has 3 valence electrons, and fluorine, like we said, has 7 electrons times 3 of them. There's 3 of them here. That's 24 electrons in total. I'm going to connect all of the elements to, all of the atoms in the compound to the central atom, which it's going to be Bf3. And again, this is an arbitrary or random shape. You're going to see that there's going to be intentional shapes, and that's later in chapter 10. And so now I've made my 3 bonds of the Fs to boron, and I've used 1, 2, 3, 4, 5, 6 electrons, and I have 18 electrons left. And then the next step is to give the non-central atoms an octet. So all over here in these first 2 boxes, I've kind of done the first 3 steps. You count the total valence electrons, you put the elements around the central atom, and then you subtract from your electron bank for the bonds that you made. And now I'm giving my non-central atoms an octet. Each fluorine right now has 2 electrons because of the bond. So I'm going to put 1, 2, 3, 4. I'm going to give it 6 more to get that 8 for that octet. 12 electrons. 1, 2, 3, 4, 5, 6. Minus 6 electrons. Make that. 1, 2, 3, 4, 5, 6. Minus 6 electrons. I have 0 electrons left. Okay? Now, if there are any remaining electrons left over in the electron bank, place them on the central atom. Well, I have no more. If there are not enough electrons available to give each atom an octet, maybe multiple bonds are going to be formed. Well, wait, hold on. Boron does not require an octet. B has 6 electrons. Does not need an octet. So this structure is good. It looks like this. This is Bf3. Done. There are certain exceptions to having an octet. So boron is one that does not need an octet. And of course, hydrogen and helium only need 2 electrons, does not need an octet. And then elements in period 3 or higher, like we did with our buddy phosphorus over here, can have over an octet. Okay? So I'm hoping this video can help you draw Lewis structures that disobey the octet rule. If you have any other questions or concerns, let me know. My next video will zoom in on quick check number 2 on drawing Lewis structures and calculating formal charge.